In a previous video, I introduced a law that we can use when we've got a power that's been raised to another power, and that can be found in the links below. Today, we're going to look at using that law when we've got unknowns in our problems. So, let's begin. So let's recap the power of a power law that we discovered in the previous video. If a power is raised to a power, we keep the same base but we multiply the exponents. For example, if I've got a to the power of m and I raise that to the power of n, what we do is we keep the same base of a and we multiply the two exponents together. So let's take a look at that law when we apply it to a problem that has an unknown in it. Now throughout this video, I'm going to use two different methods with each problem. Method 1, I'm going to expand each problem and simplify it so you can see how the process works. But method 2 is the preferable way to do these problems, where we're going to apply the power of a power law to find the solution. So let's take a look here. I've got a to the power of 2 that's been raised to the power of 3. But what does this mean? Well, when we expand this out, this is the same as saying a to the second power multiplied by itself 3 times. But hang on a second, we're now multiplying indices together, so we can apply our multiplying indices law, which if you want to learn more about is linked below. But that law says when we're multiplying indices with the same base, we keep the base but we add the exponents. So this is equal to a to the power of 2 plus 2 plus 2. So when we simplify this right down, that is the same as saying a to the power of 6. Alright, so what happens when we use the law? Well, the law says when we've got a power raised to another power, we keep the base in this problem is a, but we multiply the exponents. So that's going to be the power of 2 times 3. Now if you think about it, looking over the left here, this kind of makes sense because multiplication is repeated addition, and what we've got here is repeated addition. We have 3 lots of 2, or 3 times 2, which can be written as 2 times 3. So that is equal to a to the 6th power. So as you can see here, both methods arrive to the same solution. However, when we use the law, it's just that little bit more efficient. But let's take a look at a problem that has more than one unknown. What do we do here? Well, let's first expand this problem. What is this actually saying? Well, when we expand it, it's saying everything in the brackets, so that's a to the power of 2, b to the power of 4, times itself 3 times. But hang on a second. Now what we've got here is just nothing but multiplication between each term. So let's write that out. That is equal to a squared times b to the 4th multiplied by a squared times b to the 4th multiplied by a squared times b to the 4th. But when I've got nothing but multiplication, I can actually rewrite this problem in any way I like. So what I'm going to do is I'm going to collect the a terms together and I'm going to collect the b terms together. And what you'll notice is we're back to our multiplying indices law, where if we multiply something with the same base, we add the exponents. So that is equal to a to the power of 2 plus 2 plus 2, all multiplied by b to the power of 4 plus 4 plus 4. When we simplify this down, that is equal to a to the 6th power times b to the 12th power, which is equal to a to the 6th power, b to the 12th power. Okay, so let's have a look at what happens when we use the law. The law says that when we're raising a power to another power, we keep the base but we multiply the exponents. In this case, 2 different powers are being raised to the same power, so we keep the base of each but we multiply the exponents of each. So that is going to be equal to a to the power of 2 times 3, and that's multiplied by b to the power of 4 times 3. This of course is equal to a to the power of 6 times b to the power of 12. And what you'll immediately see now is by using the law, we've found a much more efficient way to arrive to the same solution. But let's check out one more problem. Let's check out what happens if we've got more than one unknown, but also a coefficient. So once again, let's start by expanding. So this is equal to everything in the brackets, 2a to the power of 3, b, times itself 3 times. But now you've guessed it, we've got nothing but multiplication in this problem. So we can rewrite this without the brackets. And because there's nothing but multiplication, we can rearrange it in any order we like. So now I've ordered it with the like terms together, let's simplify it. Now here I've got the same number multiplied by itself 3 times. So that's 2 to the power of 3. In the next one, I need to use my multiplying indices law. So that's going to be the same base, but add the exponents. So 3 plus 3 plus 3. Then the final one, I'm multiplying b by itself 3 times. So that's equal to b to the third power. So when I simplify this, that's equal to 2 to the third power times a to the ninth power times b to the third power, which can be written as 2 cubed a to the ninth power b cubed. But you're quickly seeing here that there are a lot of steps to solve that problem. So let's use the law. The law says that when we raise a power to a power, we need to multiply the exponents. But hang on a second, 2 doesn't have an exponent written. B doesn't have an exponent written. But they actually do. They're raised to the power of 1, but we just don't write them down. But if I was to, this is equal to 2 to the power of 1 multiplied by a to the power of 3 multiplied by b to the power of 1, and all of that is raised to the power of 3. So now that's sorted, let's use our law. Now our law says if we're raising a power to the power, we keep the base but multiply the exponents. So the first term is going to be 2 to the power of 1 times 3. That's going to be multiplied by a to the power of 3 times 3. And that is going to be multiplied by b to the power of 1 times 3. This is equal to 2 to the power of 3 multiplied by a to the power of 9 multiplied by b to the power of 3, which can be written as 2 cubed times a to the 9 times b cubed. So as you can see, by using the law, we have a much more efficient way to find our solution. So now I would like you to have a go. In front of me are 6 problems that I'd like you to simplify and leave your answer in index form. I'd like you to use method 2, which was applying the power of a power law. But remember, you can always check your answers by expanding and simplifying.